So question 22 from the homework, they tell us the following information. I've got a ethylamine. Ethylamine is a base. And that concentration is 0.5 molar. And they tell us the pH of this solution is 2.10. And they want us to find the Kb of this base. So these questions are a little bit longer and a little bit different when we're working from the base side of these, because they've given us pH, right? And so as we've seen before, the generic expression for a base, if I have a base, it's going to react with water to form conjugate acid and hydroxide. So that would make my Kb expression, right? The concentration of the conjugate acid times the concentration of hydroxide all over the concentration of the base. And now you can see our problem. Our problem is they gave us pH, but pH is related to hydronium. I don't have hydronium in my Kb expression. I have hydroxide. So this is where the extra steps come in. There's multiple ways we can go about this. I'll just go one way, but there are other pathways you could use. You're going to get the same answer. I'm going to start with pH plus POH equals 14, because that'll let me find POH. When I find POH, I can find hydroxide. And when I find hydroxide, I'll also know the concentration of the conjugate acid. So I've got a pH of 12.1 plus POH equals 14. So POH equals 14 minus 12.1. So the POH of this solution is 1.9. Now that I know POH, I can find hydroxide. So that was step one. Step two, hydroxide equals 10 to the negative POH. So my hydroxide equals 10 to the negative 1.9. All right, hydroxide concentration equals 1.26 times 10 to the minus 2. Because we found hydroxide, we also know the concentration of the conjugate acid, because again, they should be equal concentration. They're formed in the same 1-to-1 ratio. So now I can find the Kb. All right, so step three, we're going to just plug in to find the Kb. So I got 1.26 times 10 to the minus 2 times 1.26 times 10 to the minus 2, all over the initial concentration, 0.5 molar. All right, so I'm going to square that, divide that by 0.5. Divided by 0.5, and I get a Kb for this base of approximately 3.2 times 10 to the minus 4. All right, so anytime we're asked to find Kb for a base or the pH of a base given Kb, those calculations are always going to involve a few more steps, because we're going to find hydroxide and we're going to have to convert that to hydronium to find pH, or we're going to have to convert that to POH to find pH. So we had to do the same thing here, because we started with pH and we were looking for the Kb of a base. So we had to find POH to find hydroxide before we could start the real problem and do the calculation for Kb.